House H of an angular is at a distance d from bank OA of a bay AOB and a distance L from the corner O. So there is an angler. Angler is a person who fishes by hobby, and this is the house of that angler. And this angler is at a distance d from this bank. This is a bank. This is also a bank. This is all water, and the angler can walk on the ground with a constant speed v and swim in the bay with a constant speed u. Okay, so walking speed is given as v while swimming speed is u. One day he decides at his house to fish somewhere on the bank OB. So this angler from this house wants to reach somewhere on this bank OB and find the minimum time. So he wants to go to this bank as soon as possible. So for that he'll have to walk some distance and he'll have to swim remaining distance. So has to adopt that path which gives minimum time to reach to this bank. Okay, so we have to find that time, that minimum time. Okay, let's see how to do this. So this is a water, and this point is O as given in the question. So this angle is given as theta. This is the house of that angular, and this distance is given as L from O. This is suppose the distance moved on ground, and let this reaches angular to the point P, and suppose this distance is m, then from P to this bank the angler will have to reach to this bank. uh, Suppose P is at a distance x from O, and when angler has reached to this point P, then obviously to have minimum time he'll have to swim along the shortest path from this P to other bank, and the shortest path will be a path that lands this bank perpendicularly like this. So angle here should be perpendicular, because once the angler is at P, the other bank is at at various distances depending on where he wants to reach. Suppose from P, if he goes to this point, or he can go to this point, or he can go to this point. So if you compare all these paths, the shortest one is the one which lands along this bank perpendicularly. So this will be the path uh, along which the angler must move once he has reached the point P. Okay, and suppose this path takes the angular at the point Q, then PQ will be x sine theta from this triangle. This is perpendicular here, theta angle is made here. So if this distance is x, this will be x sine theta. This is L. Okay, cos phi from this triangle using cosine rule. If you remember the cosine rule, cos of angle phi is given by this expression. And from here we can find the value of m as a function of x in terms of x, and the time will be m distance is covered with a speed v, so m by v. This is a time to walk along the ground, plus this is the swimming time pq by u. This is the swimming time, so pq is the length which is swimming, and the swimming velocity is given as u. So this is swimming time. So the total time taken is given by this expression. Okay, so just putting the value of pq as x sine theta, we have this expression. Because time is varying with respect to x, time is a function of x. So for what value of x, even m is a function of x. So time is a function of x, and we have to find that x for which time is minimum, and that will occur when dt by dx comes out equal to 0. So this you verify. I have differentiated t with respect to x and put equal to 0, and this will give dm by dx, the value of dm by dx. And for convenience I have written v sine theta by u as k. Okay, now differentiate this expression, so it will be you can verify m square as 2m into dm by dx, L square being constant, the differentiation of L square is 0, and remaining terms are differentiated. And just to cancel the 2 from the equation, so we have these two equations. So now just simply put the value of dm by dx as minus k in this equation. So the equation turns into this form, and squaring both sides, it will lead to this equation. Now we have two equations, this one and this one, both in m square. If you subtract one equation from the other, x square term will get cancelled, and so will this term 2lx cos phi. This will also get cancelled. I'm sorry, this is phi here, because on a squaring we'll get 5. This is 5. Okay, and even this term will get cancelled. So we'll be left with a simpler equation. And one more thing, sine square phi. This distance is given as d. This is given as d. So sine phi from this triangle, you can verify that L sine phi is d. So L sine phi is d, so it becomes d square. Okay, then m from this equation, m comes out equal to this. On just putting the value of k, we get this. K we have found earlier. This is k. From here, I've just put the value of k, and now using this equation, this one, just put the value of x from x. You see from this equation. Yeah. So from this equation, if you find x, it will come out L cos phi minus mk. So I've just put the value of x here, L cos phi minus mk, and remaining term, uh, x sine phi upon u. So this is okay, upon u. And then what I've done, I have collected all m terms in one term and the remaining in the other term. And also I put the value of cos phi as 1 minus L cos phi. The value of L cos phi, if you can verify from here, what is L cos phi. So come to this triangle. So L cos phi is nothing but this distance, and this distance is from Pythagoras theorem. This is under root L square minus d square. So that's why I've written this L square minus d square. Okay, let's verify this is the equation of this. Then simply putting the values of m and the solving, we get this expression of t. This is the minimum t in which the angler can reach to the desired bank. Okay.